Yet another example of an irrational number. Don't forget, an irrational number is a number that cannot be expressed as the ratio of two integers. And we use the symbol that for the irrational numbers. What we call surds. Now, surds involve what's called the radical sign. The radical sign, you may be familiar with the square root, but it's not just the square root, because the square root is defined as the number which multiplied by itself gives us the number that is there. So for instance, the square root of 9, what number multiplied by itself gives us 9, and that'll be equal to 3. But also, surds don't have to be the square root, they could be the cube root, or they could be the 15th root. So all of those numbers, and these are numbers, and I'll show you how we'll get these on the number line, all of these numbers are examples of surds where this is an integer. Okay, so let's go back to our number line, and we've got 0 and 1, and if I could measure that very, very accurately and at right angles go up the same length, that is 1 and that is 1, and if we look at Pythagoras' theorem, we know that that squared plus that squared will be equal to this squared. So this squared is 1 squared, which is 1, 1 squared, which is 1, 1 squared plus 1 squared is this squared. So this is the square root of 2. And then if I could measure that and bring it down onto the number line, there we have the square root of 2. So there's the number 2. It won't be up as far as 1.5. And likewise, if we put a 1 up there at right angles and could measure that accurately, that squared is 2, that squared is 1, so that 2 plus 1 is 3, so this will be the square root of 3. And then we could go and get the square root of 3. So these numbers, once again, help to fill in our number line. Surds, square root of number, cube roots of number, fourth root of numbers, help to fill in all the dots that are between the integers. For this course, we're just going to look at the square root. So the square root of n, where n is an integer, and obviously it'll be positive because at this stage we're not worried about the square root of negative numbers. So n is a positive integer. The square root of n is what we will call a surd. We need to be able to manipulate surds. And by manipulate, I mean things like add and subtract, multiply and divide surds. And the first thing we're going to do though is simplify surds. Let's just do that again. Simplify surds. Now, to be able to simplify surds, we need to be able to have a good knowledge of what are called square numbers. If you were to just put down your counting numbers here, you can go as far as you like, and just square each of these. So this is 1 squared is 1, 2 squared 4, 9, 16, 25, 36, 49, and so on. These are the square numbers. And the reason we need to know the square numbers, if for instance we want to simplify the square root of 24. Now square root of 24, we look for the biggest square number that will divide evenly into 24. Well, 1 certainly will always go into these numbers, but 4, okay, is there a bigger one? No, there isn't. So 4 is the biggest square number that goes into 24. So we can factorize, if you like, the 24 into 4 times 6. Now we can split that into 2 square roots. Square root of 4 times the square root of 6. Now if there's no sign written there, it's understood to be a times. And the reason we use the square numbers is we know that we can find the square root of that number. Square root of 4 is 2, so it'll be 2 root 6, and that is root 24 simplify. Square root of 75. We look for the biggest square number that will go into 75 evenly, and we scan across, and we come up with 25, so we can write that. Now probably when you're doing these you don't need to put that intermediate step, we can just go straight to this. So the biggest square will be 25, so that'll be square root of 25. What have we got to multiply 25 by to get 75? Well, the answer is 3. And now we can simplify the first bit. The square root of 25 is 5. Root 3. So that's how to simplify surds. The next step is to add and subtract. Like surds. Now like surds, so it's like if you had 5 root 2 and 8 root 2, they are what I call like surds because the square root is of the same thing. Don't get confused though. If you had 3 root 8, that is like to these as well, because don't forget we can simplify this to 3 times. Now root 8 is root 4 root 2, and that root 4 is 2, so that'll be 3 times 2 root 2. We simply just multiply those two together and we get 6 root 2. So they are like surds, and we can add and subtract them. So sometimes there is when you're adding and subtracting, you may need to do some simplification first. So for instance, 5 root 2 plus 8 root 2, we simply add the numbers at the front. 8 and 5 is 13, root 2. 5 root 2 minus 8 root 2, we simply subtract, so it'll be 5 minus 8 root 2. 5 minus 8 is negative 3 root 2. So that's adding and subtracting like surds. When you are multiplying, dividing, surds don't have to be like. For instance, 3 root 5 times 2 root 2 will be equal to, now we multiply the numbers out the front together. If there is no number there, it's assumed to be 1, so it'd be 3 times 1, but here we've got a 2, so 3 times 2 is 6. And then we multiply underneath the surds. So we put a radical sign, and then we go 5 times 2. So that'll be equal to 6. 5 times 2 is 10, so 6 root 10. Now it's important to have a look here to see if we can go back, and similar to what we've done here, is to simplify root 10. Root 10, there's no square number that will divide into 10 evenly, so we don't worry about 1 because it's 1 times 10, so that's as simple as we're going to be able to get it. If we've got 4 root 10 divided by 3 root 5. Now another way of doing division is 4 root 10 over 3 root 5. Nothing will cancel here. We'll come to the third part in a minute. So 4 on 3, there's nothing will cancel, so we've got 4 on 3. Now instead of writing it like that, we can write it with 1 square root and just put the 2 integers underneath. And we know that 5 into 10 goes 2, so it'll be 4 on 3 root 2. All right. We might leave it at that, and come back and do some more complicated ones in the next little video. So going back, surds. Surds are another one of our irrational numbers, and there's an infinite number of surds. They are not just square roots, they are any root. So third root, the 15th root are all example of surds. This course we're just going to be looking at square roots. I've shown you how we can put some of the surds on our number line. Manipulating surds, you need to be able to simplify surds, and we do that by using square numbers and factorising. And then when we add surds or subtract them, they need to be like surds, otherwise you cannot simplify. And multiply and divide, they don't have to be like. We'd simply just multiply the coefficients or divide the coefficients and multiply or divide the numbers that are underneath the radical signs.